All right, so we're moving on to the 2.10 notes solving literal equations. So we're going to start off today's notes with this formula for simple interest. This simple interest formula is this one: I equals P times R times T, where I represents interest, P represents the principal, R represents the percent rate, and T is time, but again, time needs to be in years. So let's take a look how we use this formula to find what we're being asked to find. Cameron loaned his colleague Brett $1,100 at a simple interest rate of 7% per year for 4 years. It says determine the simple interest Brett must pay Cameron when he repays the loan at the end of the 4 years. Okay, so we need to be able to identify the information that's given. And so Brett was given $1,100, so that is the principal. The rate of 7%, so that's R. And the 4 years, that's our T. Okay, so like with any formula, we're going to plug in those values in and solve for the remaining variable. All right, so in for P goes $1,100. In for R goes to 7%. Now you notice that I changed the 7% into its decimal equivalent. So again, just make sure we do that properly. All right, 7% as a decimal is 0.07. Again, the way you can calculate that is by taking your calculator and taking 7 divided by 100, and that gets your decimal of 0.07. And our time T in years is 4 years. All right, so using this formula, we're solving for I. So we're going to take our calculator and we're going to multiply these three numbers together. All right, so we calculate an interest value of $308. I'd like to take a look at number 2. It says Mark borrowed $500 from his credit union for 2 years. The simple interest that was paid was $52.90. What simple interest rate was Mark charged? Okay, so for this one, we are looking for the rate. It says it's asking us what is the rate. So that means we're solving for R. So what I'm going to do this time is I'm going to kind of highlight the R by putting a box around it. So knowing, okay, that's the number that we're looking for. All right, so I need to find the values for all the other variables. Okay, so Mark borrowed $500. That's our principal. He borrowed it for 2 years, so that's our time T. And we see here it says the simple interest that was paid, so again, interest is a money value, was $52.90. So that's the interest, so that's our I. And so we're going to take these three numbers and plug them into the equation. All right, so after we plug those numbers in their respective spots in the equation, you're going to see that we need to simplify the left side, the right side, before we start solving for R, right? We're looking for the interest rate. It's going to take 500 times 2 to make it 1,000 times R. And we're solving for R, so I'm going to get rid of this 1,000. So I need to divide by 1,000. Solving for R, we get R, according to the calculator, is 0.0529. All right, so our interest rate, I'm going to change that to a percentage. So again, you're going to change a decimal into a percent, you're going to multiply it by 100. So when we do that, we get 5.29%. That's our interest rate. Okay, example number 3, Maria loaned her daughter $20,000 at a simple interest rate of 3.75% per year. At the end of the loan period, Don paid Maria the original $20,000 plus $4,875 in interest. Determine the length of the loan. All right, so again, we want to identify these values here. So Don borrowed $20,000. That's our principal. Interest rate, that's our R rate. And here we have the interest. That's our I. So we plug those values into our formula. 4,875 in for I, 20,000 in for P, 0.0375 in for R. Right? So again, we're looking for T, determining the length of the loan. Right, so when we multiply 20,000 times 0.0375 in our calculator, we get 750. We're solving for T, so we need to get rid of that 750. Since it's being multiplied, we are going to divide it out. Divide both sides by 750. We get T is equal to 6.5. All right, so the length of the loan is 6.5 years. All right, so now we're going to move on to solving what's called literal equations. Okay, so what literal equations are these equations that have more than one variable. Right, like some of the science formulas that you may have already seen in your science classes. But you notice here again the goal in terms of solving these, or the way you're going to solve these little equations, is again by going through the 3 steps, clearing out fractions if necessary, undo any addition or subtraction, and undo any multiplication or division. So in example number 1, we're given the formula for the circumference of a circle. Right? C equals 2 times pi times r. So for this problem, we're being asked to solve for r. Okay, so we're solving for r, okay, which means we want to get r by itself. All right, so it means the 2 and the pi symbol need to go. So how are we going to get rid of the 2 and the pi so that r is by itself? Yep, we are going to divide by 2 pi, right? Since 2 and the pi are both being multiplied to r, to get rid of it, we are going to divide it out. So I'm going to divide by 2 pi on both sides. The 2's cancel, the pi's cancel. I'm left with r equals. And on this side, we're left with an expression. Right? We're not looking for a specific numeric value for r. Right? So for these literal equations, this is what your answers could look like. Right? You got your variable by itself that you're solving for on one side, and then some combination of other variables and numbers and operations on the other. Right, so this is our solution for r. R equals C divided by 2 pi. Example number 2, we are given the formula for kinetic energy. K equals 1/2 times m times v squared. So for this particular problem, we are being asked to solve specifically for m. Okay, so with these literal equations that have more than one variable, you have to make sure you pay attention to what the problem is asking you to solve for. Which of the variables do we want to isolate? All right, so since we're solving for m, that means we need to get m by itself. Well, can we think about the 3 steps that we've been talking about this entire unit? Because we see a fraction, we know we got to clear out the fractions first. So we need to multiply by 2 to start. So I'm going to multiply both sides of the equation by 2. So I'm going to multiply this side by 2, and then this side by 2. On the left side, I have 2 times k. And on the right side, these 2's cancel and reduce down to a 1. So leaving me with mv squared. Again, we're trying to solve for m. So that means we want to get m by itself, which means the v squared has got to go. Since v squared is being multiplied to m, to get rid of it, we're going to do the opposite, the inverse operation. So that means we need to divide by v squared. What we do to one side, we got to do the other side of the equation. V squareds cancel here. So I'm now left with m equals. And on this side, a bunch of other variables and numbers and math operations as an answer. So m equals 2 times k divided by v squared. All right, example number 3, we're given this statistics equation, and we're being asked to solve for this Greek symbol sigma. All right, so we need to get that by itself. Now again, we see that we have a fraction. All right, so again, we want to clear out the fraction. So again, to clear out the fraction, we're always going to multiply by what we have in the denominator. So in the denominator, we do have that sigma symbol. So to clear it out, we're going to multiply both sides by sigma. Okay, so I'm going to multiply the left side by sigma and the right side by sigma. Again, we're trying to clear out our fractions. On the left side, I'm going to be left with sigma z. And on the right side, the sigmas cancel. I'm left with x minus the Greek symbol mu. All right, again, we're solving for sigma. So it means we need to get this symbol here by itself. So what are we going to do next? Yep, we're going to divide by z. Since z is being multiplied to sigma, I'm going to divide by z. It's going to divide both sides by z. So I'm left with sigma on the left by itself, then x minus mu all over z. All right, so let me give you some times here if you can do example number 4. So we're given this equation for electricity, and we're solving for big R. All right, so we're going to start off by subtracting IR from both sides, right? We're undoing these operations. So now we're left with I times big R equals E minus I times little r. To finish this off, since we're solving for big R, we're going to divide by big I on both sides, leaving us with big R equals E minus I times little r all over I. Okay, let's have you try one more here with example number 5. We're solving for little l. All right, so we want to clear out the fractions first. So we're going to multiply by what's in the denominator. We're going to multiply both sides of the equation by 2. I want to get rid of that n, so I'm going to divide both sides by n. And then finally get L by itself, I'm going to get rid of that A. So I have L is equal to 2S over N minus A.